In this video, I'll talk about the significance level and critical values in a hypothesis testing problem. So our significance level, which is also designated alpha, is the probability of rejecting the null hypothesis when it's actually true. So here we're going to look at our three types of tests. We have a left tail test, a two-tailed test, and a right tail test. And notice that in the left tail test, alpha is the area in the left tail. In a two-tailed test, we have to split alpha between the two tails. So we have alpha divided by 2 in the left-hand tail and alpha divided by 2 in the right-hand tail. And then in a right tail test, alpha is in the right tail. So we have our three types of tests, and alpha is just in whatever tail is appropriate for that particular problem. So how are we going to use this significance level? We're going to use the significance level to find the critical value. So our critical value for our purposes right now is just going to be either a z value or a t value that corresponds to the significance level alpha and what type of test it is that we're doing. So here we have a left tail test, first of all, where alpha is in the left-hand tail, and notice that we have negative z sub alpha is our critical value here in this particular type of test. In a two-tailed test, we have alpha divided by 2 in both the left and the right-hand tails, and so we have negative z sub alpha over 2 and positive z sub alpha over 2. So we're going to have two critical values in a two-tailed test. So sometimes you just have the one critical value, and that's going to be z sub alpha or negative z sub alpha, or maybe t sub alpha or negative t sub alpha. So it can be either z or t. It could be positive or negative. And then in a two-tailed test, we have the two critical values that we're going to have to find. So let's take a look at a couple of examples, and in the examples I think that it will be a lot more understandable. So how do we find the critical value when we're working with a normal distribution? So we want to find what is the critical value if the significance level in the problem is alpha equals 0.05, and our alternative hypothesis is that p is greater than 0.20. So when we're working with a proportion, we're always going to be working with the normal distribution. So we know that. And I'm going to start by drawing that normal distribution. We know that this is a right tail test, so that means that all of the value of alpha is in the right tail, and that's 0.05. And that means that we need to calculate z sub 0.05. I know it's z because we're working with the normal distribution. So normal and z are really potato. They're referring to the same thing. So we're finding z sub 0.05. And to do that, you can use your calculator, and you're using that inverse norm function that we used back in chapter 6. So inverse norm, we're going to take the inverse norm of 1 minus 0.05 because this is on the right-hand side. And the mean is 0, standard deviation is 1, and that gives me a z value of 1.64. So that means my critical value is going to equal 1.64. Now, what if I want to find critical values with a two-tailed test? So here we have the significance level is 0.01, and my alternative hypothesis is that mu is not equal to 1.4. Since this is a problem about a mean, we could either be using a normal distribution or a student t distribution. Since I'm told that sigma is known, I know that I'm going to use the normal distribution in this case. If sigma was not known, then I would have to use the student t distribution. So again, I'm going to draw my normal distribution. And because this is a two-tailed test, I'm going to take my value of alpha, which is 0.01, and I'm going to divide alpha by 2. So I take 0.01 divided by 2, and that gives me 0.005. And so I distribute that amongst the two tails. So I'm going to need to find my two critical values, which are z sub 0.005 and negative z sub 0.005. Now usually what I'll do is I'll start by finding negative z sub 0.005, and the reason why is it's just a little bit less typing in the calculator. So to find that, I'm going to find the inverse norm of 0.005, because that's the area in the left-hand tail, and then we do comma 0, comma 1, and we get negative 2.58. So since negative z sub 0.005 is negative 2.58, then that means that z sub 0.005 must be positive 2.58. So our critical values are plus and minus 2.58. Now let's take a look at a problem that involves the t-distribution. So here it asks, what are the critical values if the significance level alpha equals 0.01 and our alternative hypothesis is that mu is not equal to 1.4, but in this problem sigma is not known and our sample size is 25. I'm going to have to know my sample size if I'm using the t-distribution in order to find my critical values. So that's why that sample size information is given. So I'm going to draw my t-distribution, which looks remarkably like the normal distribution. And again, we have the same value of alpha as the last problem, so I went ahead and just put in the 0.005 in both tails. We're using the t-distribution because sigma is not known. So it's t sub 0.005 and negative t sub 0.005. So in order to find the critical values, again, I'm going to find the negative t sub 0.005. And to do that in the calculator, I'm going to use the inverse t function. That's right below inverse norm. It should be number 4 on your calculator. And the area that we're talking about is 0.005. And then I have to give the degrees of freedom. And the degrees of freedom is just calculated by taking the sample size and subtracting 1 from it. So if we're talking about the t-distribution, degrees of freedom is a very easy formula. It's just sample size minus 1. So in this case, that degrees of freedom is 24, and that gives me a critical value of negative 2.80. And since it's a two-tailed test, my critical values are plus and minus 2.80. And that's how I find my critical values for either the z or the t distribution.